Hey guys, and welcome back to another tech tip segment. This time we're going to be talking about recoating flybacks, in particular the type that Zenith used on some of their later generation porthole sets. This is a parts chassis. Couldn't even tell you exactly where I got it from, but I just had the chassis, don't have the cabinet. It's not going to get restored. I've been scavenging parts from it. The reason I wanted to show it to you is not what's on top, it's what's below. Notice there's no high voltage cage up here, there's no flyback up here. This was a metal cone set, so it's all plastic here, and a CRT set in here with an insulated band around it. We do have some wires coming out here. We have a high voltage lead coming out, but there's nothing up here. That's because it's all down below. Motorola did this too. A handful of other makers. I think partly, well, maybe not partly, maybe the main reason, the only reason, was to save money. So instead of having the flyback on top and putting it inside a box, they put it down below. And there it is. And what a sorry mess it is. Let's take a closer look at it. So yeah, that mess is the flyback. When I first saw one of these chassis, I wasn't quite sure what I was looking at. It's actually a normal, conventional looking flyback, as we'll see. It's just the way it's mounted and the way it's coated, you can't see it because it's all on the other side. It has the conventional high voltage donut and primary and a iron core and all that good stuff. What we're looking at is a phenolic board with some solder lugs going to windings on the flyback and a few metal donuts here. That's where your high voltage comes out. That's to prevent corona discharge. No sharp points, so they have these rounded donuts there. And these two wires are going to the filament of the high voltage rectifier. Now, for whatever reason, they decided to dip this thing into something. And that's this coating here. And honestly, this isn't as horrible as they usually look. Often I see them look more gray or black on the surface. It's probably, now that I'm looking at this one, it's probably because it attracted a lot of fine particulate matter, maybe cigarette smoke particles, considering the date. Ignore the thunderstorm in the background, it is spring in the Midwest. But this is probably just some sort of wax. But they look horrible, and I've seen them where this gets hardened and really cracking, and I think it puts stress on those little fine wires that come out. So what I want to try doing is a technique that was described on the Antique Radio forum of dipping this into a solvent which removes all of this beautifully, and then immediately dunking it into a coating. Now, in the past, I've recoated some flybacks, but usually I chipped away the coating that was flaking off and then just painted it with some Corona dope. And I've seen guys who have melted off the beeswax and then used, say, a vacuum pump when they put it dipped it into fresh beeswax to draw out the air and the moisture. So what we're trying to do is replace this coating, but also remove any moisture that might have gotten in there. And when we put on the new coating, we want it to really soak down into everything and seal it from the environment. It's there for a few reasons. One, to prevent you from getting shocked where you shouldn't, or from arcing to circuit points where it shouldn't. But also to protect all those really fine wires, all those turns in there, to hold the thing together. But this interesting new technique is you go directly from the solvent right into the new coating without letting it dry out. The idea being that when you soak it in the solvent gets down into all the nooks and crannies, dissolves the old stuff, and the solvent's still sitting in there. And if you dunk it directly into a new coating that's compatible with that solvent, the new coating will slowly displace the solvent and get down in there without ever giving moisture or air a chance to get in there. So that's what we're going to try doing. They use something called Prepsol, which is not readily available. The guys who the guy who came up with this is in Australia. So I'll tell you right up front, he used Prepsol to dissolve it and then dipped it into, I believe it was polyester lacquer. Neither one of which I can just run out and buy locally. So what I propose to do is use paint thinner. I've actually done a little bit of experimenting already, so I know it will dissolve this. So I got the cheapest, nastiest paint thinner at Home Depot. It's about $6 for a standard can of it, which is more than enough for this project. And then what are we going to coat it with? The polyester lacquer is an interesting substance, and I would like to use it if I had some, or I could get some easily and expensively. Instead, what I'm going to do is use polyurethane, multiple coats, but follow that up with super Corona dope, which I've used in the past. It comes in a little bottle. Sorry, I don't have a bottle handy, but I do have regular Corona dope, which you could also use, but this is black and sticky and messy and ends up looking kind of horrible in the end. Whereas super Corona dope is clear. It goes on like, say, nail polish. There's a little brush on the other end of this. But I warn you, it dries very quickly. It's meant for doing quick repairs, service techs. It has excellent dielectric strength. The thin layer is something like, I don't know, it's 5 or 10,000 volts per mil insulation or something like that. My point being is that a thin coating of the stuff, or a couple thin coatings, will do a beautiful job of insulating this. Because this Flyback puts out like 12,000 volts or something like that, so we don't need crazy lengths. We're not doing, let's say, a color Flyback that can run on 30,000 plus, so we don't need to get super exotic. But super Corona dope not only has great dielectric strength, but it also dries very quickly. The trade-off is that the solvents, the fumes, are very potent, and it has to be shipped via ground, because I can't put it on an airplane because it's so volatile, and you can't really get it anywhere but all the major suppliers, DigiKey, Mauser, whatever. You can order it, you can get it on Amazon. But first, we're going to start with polyurethane and dip it right into that. And once that's on there and sealed, it'll be stabilized, and then when I get my hands on some super Corona dope, I can paint it up with that. But right now, let's get this out of here. Now, I do have a practical point to this. No, I'm not restoring this chassis, but I'm restoring a very, very similar looking chassis that's in one of my porthole sets as part of the group of porthole sets I'm restoring. Just taking out some 1/4-inch sheet metal screws here. You want to be careful whenever you're working on Flybacks, because they're delicate and I wouldn't say they're unattainium, but they're not easy to get replacements for. So put off. Go into plate caps on the top side. Horizontal output tube and the high voltage rectifier. Get those snipped out. Ugh, this thing is sticky too, just to get all that much more fun. Alright, to get some lacing here. I'm going to start snipping off these wires. Of course, if you were doing this for real, you want to be very careful, because you're going to want to reinstall it and use it. And remember where all these wires go. Just about got it. I think the main thing left is those windings to the high voltage socket. Okay, I see. Yeah, they go right over here. Oh, that is gross. Voila. Look at how gross that thing is. It's like growing mold or something. That's why we want to recoat it. I think one of the portholes I restored a year or two ago. Great, and sticking to my thumb too. did have one of these, but it wasn't as gross, and I just left it as is, and it worked. This might very well work fine as is, too, but when you see the after, assuming all goes well, I think you'll understand why I would want to recoat this. Well, there's some pretty serious lightning strikes out there. I can hear sirens in the background. If there are any fires or trees get knocked down. Alright, so I'm not going to mess around. This thing is gross. This is nasty. I want to get this clean. I'm just going to dunk this right into the paint thinner. So, like so, into a plastic container, a coffee container, and we're just like I said, just cheapo, no nonsense paint thinner. The fumes on this actually are not bad. It must have low VOC, like it doesn't really evaporate and go into the air really. You have to get your nose down in there to really smell it. I hate these cans though with just a small opening because it tends to splash all over. I miss the old screw ones where you get a large diameter opening. I'll just have to do it slowly, I guess. We're going to want to completely submerge it, probably leave it overnight, and let it work its magic. I'll put this outside. There's no reason to take any risks with keeping this inside in case there's a spark or something. Just keep it away from your pets. Well, I didn't have enough to completely submerge it, but the part that's exposed doesn't have any coating on it, so the stuff we really want to dissolve is definitely down there in the solvent. I will pick up tomorrow and see what emerges from this goo. Well, curiosity's gotten the better of me. It's been, about 6 hours. Let's see how we're doing. I got a little soft brush here. Pull it up a little bit. Oh yeah, it's dissolving. Look at that coming off the donut. So I think what we're going to end up finding that there's two layers. There's white waxy layer, and underneath that there'll be the more traditional coating that's on the flyback. You want to get it all off. So, oh yeah, especially on the donut there. That outermost layer is coming right off. Now you want to be oh so careful because right up here is the output going up to this whitish wire here. At least I think that's what that is. So it looks like it's coming right off the outside of the donut here. Got a little bit of extra tape wrapped around there. Because by taking this coating off, we're somewhat destabilizing it. It's not going to fall apart, but we don't want to unduly stress things. Alright, so this stuff on the board, it's looking a lot cleaner because the outermost layer is dissolved off, but we still got a ways to go to get the rest of that off. But the actual flyback coils are looking pretty nice. So all that horrible nastiness we saw, that weird, like, looked like it was growths coming off of it, that stuff is pretty well all fallen away. Lovely. Alrighty, here we are the next day. Let's check on the progress. Oh yeah, it's all dissolved. Just take a very light touch to completely come away. And again, we have very little fine wires coming off here and there, so we need to be so careful. And some of them are not fine wires, they're just bits. So there is tape and various layers here, and sometimes you get little fibers coming off of them like this. That's not a wire, but that's a wire, and that's a wire. We need to get down in here to get this goo out. Maybe a little spray bottle of this stuff would do the trick, otherwise we can just dunk it and brush it and get it all off. But yeah, that really did the trick there. See if I can dunk this a little better. Keeps getting hung up in here. Larger tub with more thinner would of course make this a little bit easier. So I'm trying to get a little rocking action going. Alright, so I will continue to brush away and remove all last traces of it. Now I have some bad news. Apparently MG Chemicals has discontinued Super Corona Dope. That's a drag, because it was a fantastic product. I looked at the specs. It was rated for 4,100 volts of insulation per mil, which is 1,000th of an inch, which is a very, very, very thin layer. I've seen a few places still have it in stock, maybe $25 plus for a little bottle this size. And a few places have a larger container. I think it's a pint, like $75. But it has a limited shelf life. I believe it's sealed. It's good for 3 years, but once you open it, I've stored them upside down. I've wrapped tape around it. It's so volatile it dries out eventually. So you can't really keep it around long term. So we need to come up with something else. So we can keep putting on more layers of poly or whatever clear finish you decide to go with, polyester lacquer or whatnot. Or use Super Corona Dope. I'll give you a little look at it and you can decide on your own. It's very similar to liquid electrical tape. Smells kind of like rubber cement. Very sticky, gooey, ooey, messy. As you paint it on, it's thick, it's going to drip, it's going to run. So... has toluene, and methyl isobutyl ketone, and other nasty stuff. But this is regular Corona Dope that I believe you still can get. And then there is the old school red insulating varnish, which I believe is readily available. You get it from Granger and other places. And it looks like this. Common product in the electrical world for dealing with arcs and motors and relays, industrial applications, and well, again, thick, messy. So if you don't care about aesthetics, I'd be inclined to go with this. I think it's a little less messy than the Corona Dope. But if you care about looks, because part of the reason I'm doing this is just because it looks nice. Pile on the layers of polyurethane. I've tried to look for what the dielectric strength of it is, but that's a little tricky because, of course, there are multiple brands. There's water-based poly, there's oil-based poly, fast drying, slow drying. And these days you get polyacrylic, polyurethane with acrylic in it, and all sorts of weird variations. And that's not its intended purpose. It's for refinishing wood, putting on floors, so they're not going to list the dielectric strength of it. We're just kind of going with common sense that it is an insulating product. It's plastic, essentially. If we put it on thick enough, it will work. The other reason I'm going with, at least for the first few coats, oil-based polyurethane is it's compatible with this solvent, with paint thinner. So the idea is I don't want this to dry out. I want to keep this in here. And then as soon as I'm satisfied it's cleaned off enough, we're immediately going to dunk it or slather it with polyurethane. And it should work its way in there and displace the solvent. Maybe it doesn't work as well as Prep-Sol and polyester lacquer, but that's what I have on hand. And I know that paint thinner and oil-based polyurethane are compatible. Let me show you what I'm going to use. This is what I'm going to use. I could pour this into a vessel and dunk that in repeatedly and build up layers. I don't think I will though. I'm going to try brushing it on. The reason I say that is there are wire lugs on here that I need to reconnect and solder to. And I don't want to have to burn through the poly with a soldering iron. Also, we have wires, and I don't want them to become completely encrusted in polyurethane if I can avoid it. I have experimented actually with another transformer, so this isn't my first go around with this, and I had pretty good luck before with just going right from this dunk to brushing on poly with a small soft brush, just like the same one I was using to remove the dissolved wax. And just dip it in here and paint it on and let each layer dry for a couple hours and before putting on another layer. Another option would be to spray. But you're going to want to use oil-based, not water-based, because water and paint thinner are not going to mix too well. I did a little more reading and it confirmed what I had seen earlier, that the insulating properties of polyurethane depend on the exact formulation. However, it is considered to be a good insulator, have good insulating properties. So here's what I propose. We're going to go with this. We're going to put on a bunch of coats, maybe 8 or more, thin. Wait a couple hours in between. Actually, after the first coat or two, especially the first coat, I think we should wait a little bit longer because of the extra solvents in here, so maybe more like 8 hours. But once the layers seem to be setting up well, I think they recommend 2 hours between coats, something like that. I just took it out of the paint thinner bath. That looks pretty good to me. Now we don't want to let this evaporate or dry out, so we're going to start putting on the coating right away. Alternately, you could submerge this in the coating. The guy who described this technique with the polyester lacquer, just dunked it and let it sit overnight, I believe. But I think we'll be okay with this technique. The paint there looks pretty horrible. If I let this sit for a few days, the solids will settle to the bottom. You could pour off the top if you wanted to keep using it. Otherwise, dispose of it safely. So the whole idea is we do not want this to dry out and evaporate. I double checked. Oil-based polyurethane is compatible with paint thinner. So we're just going to start putting this on. And we're going to let this sit a while, because if I start putting on multiple coats, what's going to happen is the paint thinner is going to get kind of sealed inside as the outer shell cures, and it's going to get trapped in there for a very, very, very long time. The idea is for the poly to slowly displace that paint thinner. Now the real motivation for developing this technique, according to the author, was the Flybacks he was working with used DCC, I believe it's called, double cotton coated wire for the Flyback rather than enameled. This is enameled, so I don't, at least what you can see is enameled. I was told that in order to maintain this complicated wiring pattern, there's got to be some type of something down in there to keep it stable. So notice when I dissolved the coating, this thing didn't unravel. And you can see there's layers of tape and whatnot, because those can certainly absorb moisture, so that's one of the things we're trying to prevent. Like this innermost part here is a cardboard tube, so I want to make sure I get this slathered. So that's one benefit of dunking it, is yeah, it gets in everywhere. You know what I could also do? Notice there's screws on here. I could take the frame apart and just get down to this coil and the phenolic board, but I'm erring on the side of caution. I don't want this thing to, I don't want to risk breaking any of the fine wires. So I'll just get down in there as best I can. And remember, this is not a, well, what am I trying to say? They were conservative with these early black and white sets. So I find these Flybacks to be quite robust, coating aside. You get into later sets that produce much higher voltage. Like if you've been watching my series on the Sylvania Silhouette Halo light set, the Flyback is tiny, but it produces twice as much high voltage as this one does. Cost savings. Trim the fat. But these old ones, they're a bit over-engineered, I think. There we go. I put on so much it was dripping all over, which is a good thing. So I put some plastic down. We let that set up. Now, as I mentioned earlier, I did experiment with another one before I showed you, because I wanted to make sure this technique would work before I put it on film. Well, here's the other one I did a few weeks ago, and this has 6, 7, 8. I didn't really count how many layers of polyurethane are on it. And yeah, I think it's the identical. See, the part number is slightly different, so they're not identical, but they're pretty darn close. They look awfully similar. But here's how it turns out, all set up and cured. Now, of course, what everybody wants to know is, will it work? We will find out. We will find out very shortly. I don't have a set I can put it in this second, but I will endeavor later tonight to pull out the chassis for a Zenith porthole set I definitely intend to restore that uses this Flyback, but it needs to be recapped and all that stuff before we can try it out. Now, if you're wondering, hey, why don't you use a Flyback ringer? Yeah, I do have a number of ringers, and it's a built-in function in the TVA92. However, I can tell you from having tested a bunch of vintage Flybacks and ringers, especially modern ones, and they test bad. You get some rings, but it's not as much as what they consider good. I concluded that most ringers do not handle the 1940s type Flybacks correctly. So I think to really properly fully vet this, we need to put it into a working set. So be looking for that in the near future. Personally, my experience mucking around with these TVs for many years, I think this is going to work just fine. The only thing I might want to do is put on a few more coats of poly. Again, I was going to put Super Corona dope for a final couple layers on this outer donut. I don't have any, and I can't realistically get any. So I think, well, I got the poly out, let's put a couple more coats on that. Now, again, I don't have a set to put these exact ones into, so I'm going to be doing yet a third one when I pull that chassis, unless I got to check the part numbers. If one of these two is exactly the same as the part number that's in that set, I'm inclined to just pop one of these in. So that will happen probably a couple weeks from now, but I'm going to leave you off with this for now. I very much look forward to your thoughts, comments, and opinions. And again, if you don't care about it looking pretty, use a red insulating varnish. I know this will work. And if you've got Super Corona dope on hand, use it. I know that will work.